Hello everyone, so I hope you all are doing great. For today's video, our main focus is gonna be on the laws of the Newton. It was given by this Isaac Newton. Alright, let's just begin. Sorry, we have three laws of motion. Alright, I'm gonna study first law in this video, and the second law and third law is very simple. I'm gonna give the examples of that, and yeah, let's just begin. We have three laws of Newton, all right, and that was related to motion. So what does the first law states? I have this, I mean, oops, I need to cut it. I'm really sorry. That's good. Alright. And I'll just write down what's the first law. Okay. So Newton told about first of all, he told about if a body is said to be in rest, it would be at rest. Now let's just discuss what's that. Rest means a body is said to be at the state of rest. I'm just giving you the simple definition of this. Rest will be remain at rest. A body is said to be at rest will be remain at rest, alright? But in this case, the acceleration would be equal to 0 because the body is in rest. Now it is covering any distance. The body will be said to be at rest because why? Because of its environment. For example, you are sitting, right, and you are at the rest. You are doing nothing, so you're not even moving. So you are at the position of rest, all right. Then we have the force. So force would be equal to 0 as well because acceleration and force has the you know um, direct relation, alright, and velocity will be 0 as well because we know that acceleration is equal to v upon t. We have the direct relation with velocity, so velocity would be 0 as well, alright. तो ये फर्स्ट लॉ बताता है कि इफ़ द बॉडी इज़ एट रेस्ट तो इट विल बी एट रेस्ट. अगर बॉडी रेस्ट पे है तो इट विल बी एट रेस्ट जब तक कि कोई एक एक्सटर्नल फोर्स उस पर प्रोवाइड न की जाए, ऑलराइट. जब तक कि फॉर एग्जांपल अ पर्सन इज सिटिंग, ठीक है, वो पर्सन वुड बी सिटिंग जब तक मैं उसको हाथ ना मारूँ. आई विल नॉट हिट अनटिल वो हिलेगा नहीं. दैट विल बी नॉट इन मोशन until external force is applied. All right. So next definition is of uniform motion. What's that? Let's just see. Uniform motion. What's that states? Uniform motion means a body is said to be in uniform motion when the body is moving with uniform motion. The body is moving with uniform motion, uniform velocity, all right. So uniformly जा रही है मतलब एक ही स्पीड में और एक ही हर मतलब लाइक एक ही दिशा में it's going, but it's like kind of continuously it is uniformly relating, it's uniformly in the motion with its surrounding. For example, you are traveling by a car, all right? तो बाहर वाले जो, like for example, I'm gonna give you this is a very confusing example. For example, like you are sitting in a car, all right? अब बाहर वाला जो बंदा है, the outsider, and the car is moving, all right? The car is, so the outsider, in the context of outsider, you are at motion, all right? But in your context you are at rest, all right? ठीक है? And we have, for example, now you are sitting, ठीक है? Now you're sitting, but how can you say that you are at, without moving your hands and everything, how can you say that you are at rest? Because we know that earth is revolving 24/7, all right? तो अर्थ मूव कर रही है, वाई यू नॉट यू मूविंग, आप क्यों मोशन में नहीं हो? व्हेन अर्थ इज़ इन द कंटिन्यूस मोशन, वाई यू आर इन मोशन? तो तभी हमें कहा जाता है कि एक बॉडी कभी भी पूरे मोशन में नहीं होती, ना ही कभी पूरे रेस्ट में होती है, ऑल राइट? सो यूनिफॉर्म मोशन से इसका कोई ताल्लुक नहीं है. दिस इज एग्जाम्पल इज़ वेरी आउट ऑफ दैट, but I'm just gonna give you an extra additional info about that. So let me just tell you a few more points about this law. That this law is also known as law of inertia because it gives the definition of force. Law of inertia. Inertia is a quantity of matter or a mass, quantity of mass, ठीक है? Inertia means जिस body, the body that has mass will have inertia, alright? So this law is also known as law of inertia, alright? And if I could give you the example of that, for example, we have earth is revolving around the sun, ठीक है? That is moving in the uniform motion, alright? And we have moon is revolving around the earth, that is again the uniform motion. Electrons are revolving in the orbit, that is again a uniform motion. So these are the certain things, these laws are applicable till the day of judgment, क्योंकि when the day of the judgment will come, so of course this space is gonna destroy, everything is gonna collapse, alright? So that for that time these law, or till that time these law are applicable, alright? And next up I just want to tell you that when a centripetal force, alright, when a centripetal force and centrifugal force acts on a body, alright, is equal, when these two forces are equal to each other, the body is at rest, body rest पे आ जाती है, alright? And the uniform velocity, rest, you can say rest or uniform velocity, alright? Or when the uniform velocity comes, so the acceleration would be 0, alright? Rest पे होगी तो acceleration would be 0, means there would be no movement, no locomotion, alright? So when centripetal force and centrifugal force, we know that centripetal force अंदर की तरफ लगती है, inside the circle, and inside the circle it will attract you towards, and centripetal force is away. So when these two forces are equal, that the body comes at rest and the acceleration of the body gets 0, alright? So here comes the end of our first law. Now we're gonna see the second law of motion, and that is pretty cool. Alright. Nope. We'll just do it over here. I don't know what I'm doing. Alright. So this second law of motion give us the 4 parts. Okay. So this law gives the definition of This law gives the definition of acceleration. We'll prove that as well. Alright, so let's just discuss about the statement of this law. So when an unbalanced force acts on a body on acts on a body, so the body accelerates in the direction I'm gonna give you the example as well. In the direction of the force. Did you get any idea with this statement? Okay, let's just discuss. Alright, this law, the second law of motion, you need to remember that the second law of motion gives the definition of acceleration. Alright, so when an unbalanced force acts on a body, for example, this is an object, I'm kicking it. Alright, so I'm kicking it, so by this object will go forward, force की direction में it will accelerate. Alright, it will get the acceleration. Yes, it will get the acceleration. Alright, so for example, I'm just gonna give you an example. For example, cycling. Alright, cycling ki, if I could give you the example that you are applying the force, alright, and the body is accelerating in the direction of force. आप फोर्स इस तरफ लगा रहे हो साइकिल की पेडल्स पे, तो यू आर एक्सेलरेटिंग दिस वे. ऑलराइट, तो आप व्हेन यू विल इंक्रीज द फोर्स, तो when you increase the force, so the acceleration of the body will be the acceleration of the cycle would be increased as well. All right, so can I write this? I don't know why this isn't working. I'm really sorry for that. Let me just all right, so can we write this, that force is directly proportional to acceleration? All right, yes, we can say, or either we can say that acceleration is directly proportional to the force. All right, but as this law gives the definition of acceleration, so the acceleration produced by a body is, we know that directly proportional, and the force is inversely proportional to what? The force is inversely proportional to mass. How? We're gonna take again the cycling example. For example, you and your friend both are sitting on a cycle. ठीक है, you are applying force more, आपको ज़्यादा force लगानी पड़ी, and due to the mass, due to your mass, the force, I don't know what is happening, I'm really sorry. Yes, so mass, like for example, yes, आपने force लगाई, ठीक है, and due to the high mass the body is less accelerated, ठीक है, due to the mass. So we can say that force is inversely proportional to mass. Okay, so when we combine this equation 1 and this equation, we get F is equal to K M A. Alright, and when you remove this K sign, that means F M 1. Alright, K means K has the value of 1, so that will be F is equal to MA. Alright, so that is proof that the second law of motion give the relationship of acceleration, and mathematically the second law of motion is this: F is equal to MA. Alright, so now the third law of motion, that says that the body is said to be so the third law of motion states that every action has equal reaction. Frictional friction friction is the example of third law of motion. We have swimming, we have walking, and there are this flying of bird, because when a bird fly, जब the bird spread its wing, तो फोर्स नीचे की तरफ लगाती है bird, ठीक है, एंड जाती ऊपर की तरफ है. तो दिस इज़ हाउ bird is the example of third law of motion. Swimming, we have walking, friction, and us human beings sitting the way you are sitting right now is an example of third law of motion. How? Because आपको आपका मास डाउनवर्ड तरफ लेके जा रहा है, ठीक है, एंड ग्रेविटी आपको डाउनवर्ड तरफ लेके जा रही है, ऑलराइट. तो you are stable at the point, alright. So these were the topic, and for the next video I'm gonna share the MCQs and related key points of the Newton laws, alright.